Welcome, Protege. In this tutorial we're going to be talking about how to create threads. Now there are two common methods to do this. One is to use the built-in thread tool within Fusion 360, and the other common method is to use the Coil command, and that's used to create custom threads. So in one of the previous tutorials we were making an aluminum breadboard where the holes were 1/4 20. But we never actually modeled the threads because we were going to tap them. But if you wanted to model the threads in your design, then you would just use the thread tool, which is under the create tab, and if you just hover over it, it says that you can make internal external threads to cylindrical geometries. So to be able to use the thread tool, we need a cylindrical geometry, which we have with the holes that we made. And since we're using an imperial type, a 1/4 20, we can use the ANSI unified screw threads. And under size we want a 1/4 inch, and under designation we want a 1/4 20 UNC. And then everything else is default. Now by default the modeled checkbox is unchecked, so you can see that you don't actually have a thread there, but as soon as you click the checkbox then it adds a thread for you. So that's it for the aluminum breadboard. Next we're going to show you how to create, say, a threaded rod or a fastener. So first we want to create a sketch, center diameter circle on the top plane. And first I'm going to change the units to millimeter. And we're going to make an M10 screw which has a diameter of 10 millimeters. So just go ahead and dimension this. So stop the sketch, E for extrude, and we'll go ahead and make this 30 millimeters. We have our cylindrical body now, and we can use the thread tool. So for face, select the cylindrical face and make sure under thread type we want ISO metric profile. Size is 10 millimeters, and for designator we want the M10 by 1.5. Direction, right hand. I'm sure you've heard the term of lefty loosey, righty tighty. So with right hand threads, that means when we turn the thread clockwise, the thread will screw in. If we had it as left hand threads, that rule no longer applies, so we would have to turn the threaded rod counterclockwise for it to screw in. So go ahead and click OK. And I'm going to zoom in here, and I didn't check the checkbox for modeled. So if you were to save this as an STL file so you can 3D print it and then preview the mesh, it won't actually export the threads. So if you were to 3D print this, you would just get a cylinder, and that's not what we want. So to change that, all we have to do is click the checkbox for modeled. So now we do have those threads, and if we go back to save it as an STL and preview the mesh, it will now export those threads with it, so when you 3D print it, it will have those threads. One useful advantage of using the thread tool is you don't actually have to have the correct diameter. So if I go back and delete these, and we'll go back and edit the sketch, and we'll get rid of this dimension and change the diameter a little bit, and then we'll extrude this to 30 millimeters again. We can just change the size here to 10 millimeter and it will change the diameter of that cylinder. And don't forget to model your threads. And then we have an M10 by 1.5 threaded rod. This can also be a fastener if you wanted to put the, say, a bolt head on here or make it a socket head screw. But we're going to leave that off for now. So we created what are called external threads, and next we're going to create internal threads, which you use if you, say, wanted to screw on a nut. I'm going to draw the nut in this same workspace, so I'm just going to right click here and say new component. And now we can start drawing the sketch for our new component. I'm going to use polygon, draw on the top plane. We'll make this 12 millimeters. And we'll do C for circle. And make that circle 10 millimeters. Stop the sketch. And then we'll extrude that to 4 millimeters. Going to turn that body off first so we can see the nut better. So we have our cylindrical face inside of the nut, so we can use the thread tool. And again, we wanted to create an M10 nut. Click this model tab and then click OK. So now we have an M10 nut, and I'll go back and turn on the body for the M10 threaded rod, and then we'll activate this component. So notice how we can still move this nut anywhere we want to within this workspace. So what we can do is constrain it by using what's called a joint, which is under assemble. We want to select the face and then select the middle here. So we have one component selected, and next we want to select the center point of the threaded rod, and we want to make a cylindrical type. So now that hex nut is constrained to that center axis, and we can only rotate it now, which is what we wanted. Let's go ahead and do a section analysis, which is under inspect, and we'll click on the face of the nut, and then we'll drag this arrow inwards to look at a cross-sectional area. And now we can kind of look at the tolerance between the fastener or threaded rod and the nut. And sometimes you have to vary this depending on how good your 3D printer is. Usually you have to use your best judgment here and your experience with the 3D printer that you have. But if you had to change the tolerance here, just click on modify. You can choose this face and press or pull the arrow. Let's look at the front view so you can see it better. And notice how that's changing. But we're just going to leave it as is. And then to turn off that sectional analysis, we just go under the analysis tab and click the light bulb to turn it off. That's it for using Fusion 360's built-in thread tool. So next we'll go on to show you how to use Coil to create your own custom threads. So first we'll start off similar to our first example where we want to create a cylinder. Instead of using the thread tool, we're going to use Coil. It wants you to select a plane, so we'll click this top face. Then you have to select a center point, which it will rotate about. And then you have to specify the diameter, which is just the diameter of this cylinder. So if we go over and look at the parameters in the dialog box for Coil, we already have the profile selected. Under type, It's really up to you and what you prefer. Some people use revolution and height, but in this example we're going to use height and pitch since we know both of those. The height is in the wrong direction, so all you have to do is change it to a negative number, and you also have to change the pitch to a negative number as well. For the height, we can just drag this arrow, and it should be around negative 30 millimeters since that's how long we made the cylinder. But usually you want to go past it a little so the transition is nice and smooth here. Otherwise, it will look something like that, where it's kind of blocky there. So we can just go a bit past it. We just went past it by 1.5 millimeters. And you want to make sure that we want to cut out that section. And now we have a ball screw. And these are useful when you want to convert rotational motion into linear motion. So we have a smooth transition at the bottom because we designed the coil to have a longer length. But up here we have a problem where we have this rough transition. So to fix that, what you can do is we'll delete this coil, and what we can do is create an offset plane from this top face here. And we'll give that a 3 millimeter offset. So we'll go back and create the coil and select that plane. So now it'll begin from this offset plane that we just created. Click OK. Now we have smooth transitions on both the top and bottom for our custom ball screw. And that's it for this tutorial. Thank you for watching. Please subscribe below or leave a question or comment.